Hey guys, this is Mr. Bennett, and this is video 7-2. We're going to talk about ionic compounds, specifically their formulas and their shapes. So we've already talked a little bit about ionic bonds and the formation of ionic compounds. Now we want to talk about, we're going to start off by talking about their shapes, and then we'll get into their formulas. So the first thing you need to know is that ionic compounds form crystals. We talked about that last time, right? So they form a nice crystal shape. Specifically, in scientific terms, we call that a crystal lattice. So to understand that idea, what we need to first talk about is an example. So we've got sodium chloride, table salt. This really is made up of two ions. You have the cation, Na+, and you have the anion, Cl-. Okay, so you have a sodium ion and a chloride ion. If we actually look at these at the atomic level, sodium is going to be a nice positive ion or positive atom, and then chlorine is going to be a nice negative atom or negative ion. And remember, opposite charges are going to attract. So these guys are going to want to be next to each other. They do not, however, want to be next to themselves, or meaning another ion of the same charge. So a sodium would not want to be next to another sodium. So right up next to it over here, we'd have another chlorine. Now over here, we could have a sodium, because now that's sitting between two opposite charges. And here we'd have this, and then this. And so you get this nice little kind of pattern going where you're basically just alternating charges so that like charges are never next to each other. Okay, and if we do this three-dimensionally, this ends up turning into this, which is our crystal lattice. So it's this nice organized way of arranging the cations and the anions so that like charges are never next to each other, opposite charges are as close as possible. Now, the way we describe this in terms of a formula, we call it a formula unit. It's basically the ratio of the different elements in this compound or in this crystal. In this case, for sodium chloride, NaCl, it's simply a 1-to-1 ratio. It's 1 positive for every 1 negative. Easy. If you had something like K2O, so potassium oxide, which is what I have down here, okay, in this particular case, potassium has a charge of +1, and oxygen, when it forms an ion, has a charge of -2. So in order to get a nice neutral compound, you need two of these guys, two positive charges, to make or neutralize the -2 of the oxygen ion. Now, to describe that ratio, which is a 2-to-1 ratio, we simply give a subscript to the potassium. Okay, so subscript 2, and that will describe the atom that's just before it. So 2 tells us we have 2 potassiums. For oxygen, we only have 1 atom, so we don't need a subscript. We simply write a symbol. Okay, so let's talk about the rules for writing those formulas. First rule is you always write your metal first. Another way of saying it is you always write your cation first, because technically your positive ion is not always a metal. It could be a polyatomic, such as ammonium. Okay, it's a cation, but it's not a metal. It's always written first. So for instance, with table salt, sodium is written first because it's the metal, the non-metal comes second. Second rule is the charges must cancel each other out. In other words, when you add the charges up, they have to equal 0. That's where this ratio comes in to balance it out. So for example, with sodium chloride, you have a +1 charge, chlorine, you have a -1 charge, you add them together, you get 0. Okay. Last but not least, you always write the formula using the smallest ratio between the atoms. So in other words, if I was doing some weird math and I ended up with Na7Cl7, that's not the smallest ratio. That's a 7-to-7 ratio. That's not smallest. I can reduce this all the way down to 1-to-1. So you never have a higher ratio than you need. You always reduce it down to the smallest ratio possible. In this case, a 1-to-1. Alright, so let's look at an example. We have magnesium. Okay, magnesium and chlorine. Magnesium has 2 valence electrons, okay, very far away from filling up this third energy level. It would need to gain 6 electrons. So the easier way to do it is give away or transfer 2 electrons away. If it gets rid of these, if they take off, right, then magnesium's valence will now be in the second energy level, and it has a nice octet there, so it'll be nice and stable. Chlorine, on the other hand, only wants to gain 1. It has 7 valence electrons. If it gains 1 more, it will have a nice octet, be more stable, and happy. So here's the question: what do you do when one atom, or ion, wants to give away more electrons than the other wants to take? Okay, so we have a method for figuring this out quickly and easily. We call this charge, switch, drop, and reduce. I actually have a kind of a shorter nickname. I call this the swap and drop. Okay, so here are the ions again. We've got magnesium with its positive 2 charge, and we have chlorine with its negative 1 charge. So step 1 is you switch. Well, step 1 was technically you determine the charges. We've got that. Step 2 is you switch the charge numbers, but not the signs. The signs completely disappear. By signs, I mean the positive and the negative. You simply just get rid of those. We're looking at the numbers. So I will switch the charge numbers. So the 2 gets switched to the chlorine, and the 1 gets switched to the magnesium. Okay, then I drop them down so that they become subscripts. Okay, so they get dropped down below as a subscript, and then I simply put them together. So it'll be magnesium. I don't need to actually write this one. Remember, as long as I write the symbol, that tells me I have at least one of them. But chlorine, we need 2 of them, so I put the Cl2 there. So this is our formula unit for magnesium chloride, and it is the smallest ratio. It's just a 1 to 2. Let's take a look at this example over here. Same basic idea. Okay, so I'm going to do this a little faster. I'm going to do it the swap and drop method. So kind of push together some of these steps here. So I write my 2 elements, magnesium and oxygen. I already have my charges identified, so I'm going to simply swap and drop at the same time. So my 2 I give to the oxygen and I drop it down to a subscript. My 2 here I give to the magnesium and I drop it down to a subscript. So my formula ends up as Mg2O2. That's a 2 to 2 ratio. Okay, that can be reduced. So that's where this 4th step comes in. We reduce it to the smallest ratio. A 2 to 2 can be reduced down to a 1 to 1. So it just simply comes out as MgO. Okay. All right. Now let's do some practice. So this is your task now. What I want you to do is start off by determining the charges and then see if you can figure out the formula unit. As a reminder, when you're looking at this periodic table up here, remember group 1, they form positive 1 ions. Group 2 forms positive 2. This group here with the aluminum in it, they form positive 3s. And then coming from the other direction, remember the fluorine column, second to last, the halogens, form negative 1s. Then oxygen's column forms negative 2s. And then nitrogen's column forms negative 3s in terms of ions. So pause the video now and see if you can figure out these formulas. Okay, hopefully you figured them out. Let's go through it. So calcium is here, it forms a positive 2 charge. Bromine is over here, it forms a negative 1 charge. So if we swap and drop, the 2 is going to go there. The 1 here is going to go down to calcium, so we get a 1 and a 2. Put these together, we end up with calcium. I don't need to write my 1. Calcium Br2. Easy, 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 right? Just swap and drop. Potassium, first column, so it's a positive 1 charge. Nitrogen, it's right here, so it's a negative 3 charge. Okay, so we swap and drop. The 3 goes to the potassium, the 1 goes to the nitrogen. Put it together, we end up with K3N. So potassium nitride. Okay. Last but not least, aluminum forms a positive 3 charge. Sulfur forms a negative 2 charge. If we swap and drop, the 3 goes here, the 2 goes here. So we end up with Al2S3. Easy, easy. Okay, just need to learn these charges, and then it's simply swap and drop. Remember that the actual charge values, the positive and the negative, they disappear in the final formula.